Hi! This video is going to demonstrate how to solve systems of linear equations by graphing. So we have two equations here, and we eventually are going to graph them in a coordinate plane. However, usually it's easier to graph them if they are in slope-intercept form. While we can graph them by finding their x and y intercepts by substituting in 0, we're just going to rearrange them. So we want our equations to be in slope-intercept form, which means in the form of y equals mx plus b. So the goal here is to get y by itself. I want to get rid of any term next to the y term first. So there is a term with an x variable, and because it's a positive x, I'm going to subtract it to undo it using the inverse operation, and I'm going to subtract it over here as well. Now, I cannot subtract 7 minus x because they are not like terms. So I'm just going to rewrite my equation, and I will put them next to each other. Negative x plus 7. When I'm subtracting x, that x becomes a negative, and my 7 was a positive. So I'm going to make sure that I bring a positive symbol or a plus sign in front of my 7. Now, the last step to get y by itself is to get rid of that 2. It is being multiplied by y, so we're going to use the inverse operation, which is division, to divide it so that it goes away on this side. Okay? And then I'm going to divide everything else by 2 as well. And I'm left with y equals negative 1/2 x plus 7 over 2, or I can write it as 3 1/2. Okay, for my next equation, again, I'm going to get rid of any term that is next to the term I'm solving for, which is y. So I'm going to subtract 3x on both sides, and here I'm just going to write it next to it. And I'll bring down my negative 2y equals, and I'm going to rearrange the negative 3 and the 5 so that they wind up in the correct spot. Negative 3x plus 5. Okay, and now I will divide everything by negative 2. And I'm left with y equals 3/2 x becomes positive minus 5 over negative 2, which I can turn into negative 2.5. Okay, now we are going to graph both of our linear equations. I will know that I've reached a solution when both lines are plotted on the coordinate plane and they intersect at some point. So the goal in solving systems of linear equations is to figure out what ordered pair they have in common. So in the first equation, my y-intercept is 3.5. So I'm going to go up 3.5 and put a point. Okay, and my slope is negative 1/2. So I'm going to go down 1 whole and to the right 2. Again, down 1 whole to the right 2. Down 1 whole to the right 2. I'm going to do the same, or I'm actually going to do the opposite starting from my y-intercept. So I'm going to go up 1 to the left 2. Up 1 to the left 2. And I'm going to connect them the best I can. Okay, and my second equation, my y-intercept is negative 2.5, so I'll go down negative 2.5, put a point. And my slope is 3/2, so I'm going to go up 1, 2, 3, and to the right 2. 1, 2, 3, to the right 2. And I'm going to go down in the opposite direction from my y-intercept. Down 1, 2, 3. Okay, And now I will draw a line the best I can. Okay, so it looks like they cross over at 3, 2. 3, 2. That's the ordered pair where they intersect right here. Okay, so we're going to verify that by using both the substitution and elimination methods in another video. Now let's take a look at this example. We have two linear equations, y equals 2x plus 4 and y equals 2x minus 1. I'm going to solve or graph to determine their solution. So I'm going to graph the first one, slope-intercept of 4. I'm sorry, y-intercept of 4, and a slope of 2. Okay. Now I also have y equals 2x minus 1. Okay, so you should notice that these lines are parallel, and we could have also determined that by looking at our linear equations. They have the same slope, which means that they are parallel. And if they're parallel, this means that they will never meet. And if they never meet, that means there is no solution. Let's take a look at one more scenario. If I were to rearrange two equations and I get the same exact equation, if I graph those, trying my best to stay on the lines. Here's my first line. Here's my second line. Okay, they fall on the exact same line. So what do they have in common? Everything, which means there are infinite solutions, or infinitely many solutions. Okay, so that's it. I hope that you found this video helpful. If you have any questions, please come and see me. Bye.